Okay, so we're now with Brad Paley, live from Costa Rica. Hello, Brad. How are you doing today?
I am doing fine. It's a beautiful rainy day in the middle of the rainforest.
Okay, so to our audience, Brad is one of the speakers who is really difficult to introduce because of his vast experience. Some people know him for the tremendous experience of doing finance and risk analysis and optimizing interfaces for that. Others know him for his works of art. Still others know him for uh, a lot of his ideas related to cognitive engineering. Since it would likely take me quite a long time to be able to mention all the accomplishments that Brad has done in his experience, I will actually give the floor to him. Brad, can you please introduce yourself and the topic that you will be talking today briefly, and then we will switch to the presentation.
Thanks, Boyan. If it's hard for you to introduce me, it's even harder for me to introduce me. So maybe if there's a place to post a link later, we can put that there. If I say anything interesting enough for people to want to follow up and know my background, they can look that up. Thank you, though. I will talk about the work, though. By the way, it's been a pleasure working with you and your team around these serious bandwidth limitations. It's also been a pleasure working with Trifan, Colin, and the entire Astea team for over a decade, and your sister company, Hemamont, through Ludmil for 2 decades. We've been together for a long time. A great honor to have been asked to talk. And it doubles the honor to have me speak in front of the people of the Sofia University Faculty of Mathematics and Informatics. I have a lot of respect for that institution and Bulgarian engineering in general. In this talk, I'm doing my best to respond in kind. Instead of a teaser or a dog and pony show patting myself on the back, I want to do the beginnings of an actual technology transfer, sharing not just cognitive engineering results. I want to share where it came from, how it works, through some of my examples. I might have overreached. As you know, this field is so hugely interdisciplinary. Even doing a summary, I ended up with 90 minutes of final videos for this 40-minute talk. But I decided instead of dumbing it down, I just chopped half of them, and I just chopped half of the videos in half. I basically gave you the full videos, but for broadcast, I stopped each video after the first example. So you'll still get an in-depth first traversal of the core concepts of cognitive engineering, and people can get more if they want. I will give a little teaser about what's been chopped, just to let you know. If you're interested in how cognitive engineering synergizes with the visual richness we get out of graphic arts, that was cut. If you're interested in how I sped up New York Stock Exchange brokers from 10 seconds or 12 seconds to less than half a second for their most common operation, that was cut. I also cut how I could draw a 6,000 node, 20,000 link digraph that wasn't a hairball. You can actually still make actionable insights from it. And it's on paper, which is ironically more interactive than a computer. That was cut. And then finally, one of my favorite and most boring projects was where I took psycholinguistic thought chunks, put them on a screen, and I made screens a quarter of the size. And that let us deploy a system that had 30,000 screens, one for each financial instrument. It was deployed to people who had never seen the system before. There was not a question, there was no training, and they loved it. And that's all not Brad being clever, that's cognitive engineering. Those things aren't left on the cutting room floor. People can watch those uncut segments, and I think you'll post links to the full videos later. One last thing I'd ask is this is all brand new footage. I put it together just for you guys, for your audience, so I appreciate your indulgence for any glitches, but I'd also love to hear what's not clear. If I didn't properly support something, everything is supported. What you liked, but I'd especially like to hear if it engages people's imagination or if they have something to contribute to this body of knowledge. It'll only go forward if we all take it forward. I'm done. Roll the videos,
Okay.
I guess. Thanks a lot.
Thanks a lot, Brad. Yes, we will indeed now switch to the videos. As I mentioned to our audience, bandwidth in Costa Rica is very low, so that's why instead of having a live video screen sharing and audio session, we will switch to pre-recorded videos, and after them, the audience will have a chance to ask any questions. So thanks, Brad, and moving to the videos now.
Good, thanks.
I'd like to change how you think. Not about some specific point like most talks. I'd like to change the functioning mechanisms of your thought processes. Humans are still relevant in this world. We're even necessary. We're necessary as consumers to feed the engines of commerce. We're also necessary as makers for certain analytical and decision-making processes. Cognitive engineering, essentially reverse engineering the human mind so we can engage with it more effectively, can serve both of those goals. Disclaimer, I'm more interested in the structured thought processes of the makers. There seems to be plenty of progress mining our Twitch responses to make us better consumers. So what do I mean by reverse engineering the human mind? The mind has an I/O protocol. I hope to demonstrate that we use it poorly. And if we learn about its actual mechanisms, how it really works, we can connect to them better. Some say you can only get to one point in a talk. If that's true, here's the point I'd like you to take away. To effectively engage human minds, we need to format our outputs to fit the mind's input protocol and vice versa. I want to add this color to that idea. We're doing only a first approximation job of this right now with our current UX and interface and even visualization techniques. The UX and interface techniques were largely developed in the 1960s and especially in the 1970s. And the visualization techniques that actually take hold were developed in the 1600s and 1700s. These are not new ideas. What that means is there's a huge opportunity to improve existing processes and products, and there's even more opportunity to invent new ones if we can engage with our minds better. The second bit of color is that if we do this in the non-recurring engineering phase at the beginning of a project, that hugely multiplies the value of the project that we put out into the world. Many good engineers, graphic artists and UX people, are already doing parts of what I'm calling cognitive engineering. I'm sure a lot of you will recognize many of the points I'm about to present, but it needs to be called out as its own distinct discipline. So its different perspectives, procedures, and goals can be knowingly and synergistically applied, and so that we know when to apply them in the process of making something. They have a place in the development cycle. We also want to call out cognitive engineering so that it's explicitly assigned value for a cost-benefit analysis, then rationally applied or omitted on a feature-by-feature basis. Engineering's been defined as applied science. We're going to apply cognitive science and perceptual sciences as opposed to physics and logic like computer science. But surprisingly, many of the patterns that we use in computer science apply to the human mind. For instance, I'd like to apply one of the most basic engineering patterns, divide and conquer, to the perceptual and cognitive process. Here's the brain of a monkey with the key parts of its visual perceptual processing labeled. One of the key things that I learned by watching hundreds of scientists present in dozens of perception and cognition and even philosophy conferences is that their concerns are really valuable to us, but they're not exactly aligned with ours. They're looking for how these mechanisms work, and that's what this slide shows us. We're looking for how to use those mechanisms, how they function when we do tasks in the real world. That requires a slightly different partitioning. The mind's input protocol, as opposed to the brain's functioning, or at least a first approximation of it, goes from perception to recognition to association, understanding, analysis, and insight, all done in the forebrain here, and finally to action. But we need to keep in mind how those lower level mechanisms work so that we can engage with them. We have a dual task. Use them properly, looking at them as a black box and as a resource that our users can apply to get to their goals. Let's keep in mind that first approximation protocol of how humans think. As I show you all the affordances that we put together, I'm going to foreground 2 or 3 things. I'll tell you the name of the broad category that we think this bunch of perceptual or cognitive capabilities fits into. I'll tell you the lower level mechanisms in that category that we tried to shape our affordances to engage, so we had a good fit with the human mind. And I'll talk about the real world experts and the real world tasks that drove our choice about what affordances to use, because all of this has to come directly from the real world if we want to get real world ideas into people's heads. So first I'm going to bring up something called text arc. It's text in an arc. Some of you may have seen this image before. It was, I'm proud to say, published in the New York Times. It's been in the Museum of Modern Art. And it's interesting that it was in the Museum of Modern Art because, in fact, it's really a nerdy tool. It shows how every word in a text is distributed during that text. It's like a history. It's tapping into perception in a very specific way. There are something like 2,800 words, maybe more, in this image. But it doesn't overwhelm us, much like the leaves on those trees don't overwhelm us, primarily because I learned how to put these words on the page by looking at trees, by looking at how they overlap, by looking at how some leaves are brighter than others, and how there seem to be little outlines. Now, maybe the outlines are built in our minds, but there seem to be little outlines around those trees. So, notice that some of these words are bigger, and that means that they occur more often. And notice next to all of these words, there's a little star. And basically that star shows exactly where that word appeared. So this is the entire text from the beginning to the middle to the end. And the word queen appeared a lot over towards 3/4 of the way, maybe a little bit before that. And it occurred even more, actually it occurred a little bit less at the end of the book, where, for instance, the king appeared a lot. I won't get into how one uses this as a literary analytical tool because we're here to look at the perceptual trick. One of the perceptual tricks was that some of the words are brighter than others. Another of the perceptual tricks is that I put outlines around them so that you could easily identify, separate, parse each word out of the background as an affordance, as an intellectual affordance. My first breakthrough, as it were, in cognitive engineering came when Goldman Sachs invited me to redesign a handheld computer that was going to be used on the floor of the New York Stock Exchange to execute trades. The challenge there was that we were the 4th group in, and every group had used standard user interface techniques, but they couldn't replace paper. This is what the traders, rather the brokers, were using on the floor of the New York Stock Exchange. They were using a pad of paper that had evolved over the years to fit the hand, that had buy and sell very clearly distinguished, even with a funny spelling, that had a box for you to put the ticker symbol. Every time they reprinted these things over 100 years, some practitioner said, hey, why don't you do this? Hey, why don't you do that? It was the best form of committee design. And in fact, contemporary user interface designers do something called participatory design, which is not unlike what the brokers did to design these pads. Goldman invited us in because those 3 or 4 groups that had designed decent systems before were not able to get onto the floor because the brokers said, we're going to lose business. That's too slow. It's too complicated. We won't be able to do our jobs. Paper is too easy. So we had a strong, big challenge. I did my best to organize standard user interface widgets and do a little bit of information layering, but I knew there was more because I had taken the classes with the brokers. I was kind of a junior broker. I became an apprentice. I wandered around on the floor with them, learning the job for 2 months, 3 months before I did this. And I wasn't satisfied that the interface looked anything like the way they thought. And so when I finally finished the first design, I said to Matt Lavica, who was in charge of the project, let me try something unusual. Let me try to directly illustrate what they're thinking with information objects, I called them at the time. And he said, go ahead. So we spent another 2 weeks and I drew pictures. The first thing I did was I just kind of copied their existing thing so that you can kind of see here the execution slip looked pretty much like the execution slip they were using. So that guaranteed that they would recognize it and be able to immediately react to it and use it. There was a harder challenge after that, though, because executions are done one by one. An execution is where if a trader tells me buy 50,000 shares, I might buy 10,000, then another 10, then another 10, until I fill the trade with executions. So they're done one at a time. But when I then go back and say, okay, which order do I want to work next? Because 6 or 7 traders might have given me something to execute. How do I decide which one to work on? And I couldn't fit 6 or 7 full pages on. So I went back and I asked them, what are the key intellectual distinctions that you have among the objects you use, among the things in your world? So when it came to illustrating an order, and when I found I couldn't fit the right number for the task, 5, 6, 7, 8 of them at once on the screen, I said, well, maybe I can distill it. Maybe I can distill it to just the basic, most important things. Most important actually turns out to mean 2 different things here. One, what are the most important affordances they need to actually use this thing? And one of them is price. And one of them is the original quality with a strike through here, because now we've been filled down to 50,000. And one of them is whether it's an agency or proprietary trade. And one of them is whether it has an amendment. But the key intellectual distinction that they were making was, is it a sell or a buy? That was the most dangerous thing to get wrong. So the second thing is not just the affordances that they use, but I wanted to illustrate the affordances that were the most burned into their brains because they were the most dangerous. They were the most critical affordances to get right. And whether it was a buy or a sell order was one of those defining characteristics. So you see, I kept the same structure as that pad with buy on the left and sell on the right, so they'd recognize it, even in this new world. And I ended up making objects that captured all of the intellectual distinctions they needed, but were heavier on the sell side for sells and heavier on the buy side for buys. When we called some of the key brokers into the room and I ran this crazy idea by them, it wasn't crazy at all in their minds. They looked at the screen. Actually, they looked at the whiteboard where I first drew it out. And they said, oh, that makes sense. That's how I trade. I understand those objects. And I knew I was onto something. When we finally finished implementing this thing, and we deployed it about a year later, the Goldman brokers immediately took it up. There was no training necessary because they recognized what was on the screen, and they were absolutely the fastest on the floor for 2 or 3 years. I'm happy to say it was written up in ID, an industrial design magazine, and I want to share a quote with you. There it is at use on the floor, and here's the end of the article, and this is what made me realize that this was worth pursuing. It's hard to let go of something you've been doing for a long time and do something new. The handheld, the computer, as opposed to paper. But Brad's given us an ergonomic shorthand. You don't need to learn it. You grab it with your eyes. Sounds like the ecological psychoacoustics hearing the mechanical properties of the object, huh? You grab it with your eyes. And that's what I've been trying to do ever since. Make things people just grab with their eyes, recognize instantly, bypass all of that indirection, deal with the things that they want to deal with in the real world rather than a system and user interface design rules. We want to illustrate directly the things that help people think and let them play out their processes on the things they recognize. The specialists, another group of people on the floor of the New York Stock Exchange, had a different kind of job. They were the people who stayed still and the brokers would come to them, and their job was to keep a market moving. And keeping a market moving meant not just executing something, but associating that one execution with how the entire market was working. This is a screen that we built for the specialists, which had 5 to 6 times as many characters, if you use characters as a count of the information density of a screen. Or if you realize that we put these little spark lines in here, and they could make dozens of inferences based on this little tiny thing, there's probably more like 50 times the information on here. It's a harder to quantify, but better metric for user interface design, not counting clicks or characters on the screen, but counting the number of insights you can derive from it and actions you can take. Because after all, that's really the game. It's not about the screen, it's about the behavior, insights and actions, not clicks and affordances. You would be able to click on any one of these, like GE. That would bring all the information for you to associate into this big window. And you could see the past, you could see the past few trades in detail, and you could see everybody who was waiting to sell at certain prices and everybody who was waiting to buy at certain prices, once again with the market in the middle. Being able to associate one action with its context reaped even bigger benefits, because when one big buy order came in, say way up here, it would sweep up all the cells, and it might sweep up all of these and send the market into wild gyrations. This happened many times. And so what the New York Stock Exchange did was they created this stopping level. You can see this is big in red because the entire market has stopped, waiting for the specialists to decide whether this order should be allowed to go up beyond the double nickels, as they called it, 5 cents up and 5 cents down. Sadly, they renamed it to liquidity refreshment points. Double nickels is a far more resonant idea if you're looking for metaphorical grounds for task-specific information to be stuck to. But it had to sound more professional. So this order came in above the liquidity refreshment points, swept up all of the sell orders because they got bought by this person, and froze the market. The specialist had to decide, looking at all this information, whether they should click this button and unfreeze the market and let it continue to go up because it was an organic move, or whether it was a fluke and they should leave it frozen and let more sellers come in and get gobbled up by this, but then settle the market back down to where the market used to be, or some approximation of it. An extreme example of association of information on a couple of different levels as the essence. XTL was our attempt at redesigning an EMS from the ground up. For our purposes here, we're interested in understanding. So I'm just going to call out those bits. EMSs have what they call an order blotter. The blotter is basically just a big grid. The main thing to realize here is that we were organizing things around thought chunks, around the way that traders not just associated the bits of information, but understood how those associations built higher order concepts. So for instance, the first block here is the price, the bid and the ask in the intraday chart. Then there was a whole understanding chunk of order-related information. The portfolio manager is the person who passed the order down to the trader, so those are right next to each other in similar coloring. And then there are 3 ways of analyzing a stock that need to be understood together. Fundamentals include the market capitalization, the size of the firm, performance of peers and weightings. Technical analysis is basically following the shape of the curve and how it changes. Quantitative analysis is stepping more towards what's being done today. Here we associated things that we knew needed to be understood as a block. Then we started to go out and say, well, now that we're dumping all of the information you need in front of you and making you do all the work, I started to ask, what are the specific things we want to spot optimize around? What are the specific things that take you a lot of effort but mean a lot? One of the first things they said was, give us some alerts when a certain parameter, like the arrival price, is outside of the normal distribution or outside of the plotted distribution. When it's really in the tails, give me a red alert. When it's kind of approaching the tails, give me an Amber Alert. And this was a special purpose tool for the understanding of alerting. We went on and I asked, give me another example. This was a serious success because once we showed this to people, one of the guys said, gosh, I don't need the order blotter or the alerting tool anymore. This will let me do everything I care about. And it does that for one simple reason. I asked him, what are the two most important things he has to pay attention to as a trade goes through the day? And it wasn't alerts. So I said, what are the two most critical things you need to track? And they said, well, how much is it going to cost? A low to a high ranking. And how much of a footprint do I have? If the market only trades 10 million shares of this and I'm buying 9 million, I'm going to move the market. And therefore, I need to know that to figure out how to sell it. This is a scatter plot. It's a modified scatter plot, a rank scatter plot. And finally, if you said, well, gosh, it's the high-priced ones that are a big part of average daily volume that I want to pay attention to, and you double-clicked on this one here, you would get one of these, and you would use this to do one other special purpose task, which is, now that I know I'm focused on this order, who should I give it to? This was a fantasy to them. They never even looked at more than 2 metrics, let alone all of them by all of their possible venues, all the people they could have given it to. And so this just took their direction and all the data that was there in their system and presented it to them for a qualitative difference. This isn't just more data. This is something they could never do before. They can come to an actual definite answer, not hoping that they haven't missed any issues, but knowing that they haven't. The most important thing about this idea of going from a one-size-fits-all, one blotter will give you all the information and you have to figure it out approach. And I want to add, by the way, that they didn't just use the EMS order blotter. They had Bloomberg, they had email, they had their websites, they had connections to other special purpose services that would give them research results. They had 5, 6, 7, 8, 10, 15 different applications open, and they had to integrate all of this information. What we were doing was we were saying, no, that's our job. We can integrate the information for you. We were essentially refactoring their workflow. The real game here is, once again, another engineering concept of refactoring. The role here is a trader, and in a normal situation, they have a bunch of different things that they do, like these different tools were built to do different things, right? So these different tools would live here in this diagram, all these different workflows, and for every workflow, the person themselves had to use one or more applications. And this is not an unusual, in fact, this is an underestimate of the kind of task switching that a human being has to do on a trading desk. One of the reasons I'm so interested in trading as an intellectual endeavor, understanding how they work. It's an excellent set of case studies. And then these applications were connected to data feeds or destinations or things like that. Once we refactored it, every workflow had a tool, and the tool had all of the information necessary. The trader only had to go to that tool and do what the workflow meant. So you see all of this very complicated, error-prone, difficult stuff that we're now, most people thought it was impossible to deal with. This is one of the main reasons for a move towards AIs on Wall Street, because they think there's too much information. There's only too much information because we haven't factored their desktops properly. If we gave them one tool for every project, and maybe the tool would involve an AI, that's fine. But if we gave them one tool for every task that they had to do, we've removed all of this cognitive load, all of this error possibilities, all of this effort and wasted time and money. It's completely gone, you see. And now the complexity doesn't go away, but we are coding the complexity by saying, hey, tool, you have to talk to all of these microfeeds, or you have to clear at all of these venues. I want to suggest, though, that that is our job as systems engineers, and the only way we can properly do it as systems engineers is by doing a cognitive engineering analysis to figure out exactly what the human workflows are and what the human task switching costs are. Cognitive engineering drives systems engineering, or it should, if you want to get. Now, I wanted to give you a deep dive into the first few layers of our protocol, because I wanted you to see where they were coming from, that they came from a basis of science, or at least first principles, evolution, all the way back 500 million years ago when the eye was evolved, evolutionary principles. Why? Because then I'm not showing you something that you have to copy. I'm showing you where it came from so that you can build on it and generalize from it. But I'm going to lump the last three things together. And I'm going to do that showing off the pool. This environment that I've been using is a slideshow. It's a little bit more than a slideshow. For instance, I'm going to bring up SEC reports. Hedge funds, for instance, are among. So here are the reports. We can go to the actual documents that the SEC provides, take a look at them if we want to, for instance, in XML format. And if you're a coder, this might look like good news because XML means it's somewhat computer and somewhat human readable. I'd say not the best of either, but that's a topic for debate over beers. Let us instead drag this URL straight from the browser into the pool. And the pool has a module built for turning it into items. Now, what's an item? It's a way for us to, for instance, if we want to see Maverick Capital's information laid out in sectors, that sector circle, I didn't name it that for you before, but I showed it to you earlier in the talk. We can take these items, pipe them into here, poll the SEC and send it, and have another force-directed placement scheme. Lay the information out into those same sectors. So here's the IT and the software and technology and all of the things that we saw earlier in the supply chain image. I can do a little bit of analysis too. Let's say I'm interested in just looking at the largest positions. I can pipe the same data into something that lets me look at this stuff by attributes, where each attribute is a column. And I can take a look at the values. Let's sort by that, pull it over, and once again sweep our ranges out and say the middle ranges I want you to highlight in blue, the high ranges I want you to highlight in red. So not surprisingly, the big boxes, so we've got some Adobe and UHS and Facebook in our high ranges here. And then finally, we'll take a look at some insurance data. Just drag a spreadsheet into the pool, open it up, and you can see that it's a lot of columns and a lot of rows of information. This is essentially a data cube. And we can once again look at it in the attribute viewer and then slice it up like a data cube with our dicer. Bring in the data, stream it in with this little streaming port. And now we can, for instance, open up the dicer and make a very coarse-grained map if we want to, because Bing's idea of latitude, we can map to across buckets. Bing's idea of longitude, we can map to down buckets. And what good does this map do us? Well, it gives us a spatial distribution already. There were 152, a large concentration of things here, 100 here. Even more interesting, though, is if I want to go to FFE, which is first floor entry value. This says how far your front door is above the flood zone. What I want to do is I want to sweep out one of those ranges again so that I've got high ranges in different colors. And finally, use my slicer and dicer to get a color bar console. What's a console? Well, all these things are consoles. I can just drop a console into the dicer, and instead of just getting a count, I can get a full bar chart. Now, this bar chart is just a cooked-in bar chart. The idea is that we'll have a console dedicated to each specific task. Just like in XTL, we were dedicating a tool for a task. So you've seen 3 different circuits, they're all still here, of how the pool could be used to pool your resources, and that includes your intellectual resources. What you can also do, for instance, is make a subroutine by grabbing all of these things into a module, generalize it a little bit by saying, hey, maybe I want to plug in any old sensor, and maybe I want to take an output of this alarm to trigger something else, or at least maybe just read the information coming out of the alarm into a datascope. Those datascopes are very handy things. You get the idea. Peter Kennard and I have been working on the substrate of this, the visual and user interface parts of this, I think for 20 years. And the place we're hoping to take it is to have people able to have strongly typed language. All the data flowing over these wires and these messages is strongly typed. And yet have it be easy to put together and easy to share with other people, perhaps even if you're not a programmer. That would be truly democratizing access to data. So I keep harping on talking to your final audience. I call them experts because they're all expert in something or other. This isn't computing for the rest of us. This is computing for the expert in each of us, computing for the best of us, if you don't mind the bad rhyme. And where it ends up is not just better computing platforms like we hope the pool will become, but better insights in some of the most complex things that are going on in the world right now. The world is run by organizations, is run by corporations, and they are so complex, the CEOs, that nobody knows what's going on inside of them. A buddy and colleague of mine, Mark Heslop, and I are trying to attack that using cognitive engineering, but I'm going to let you hear him say it because he's the expert.
Hey everyone, my name is Mark Heslop, and I co-founded Cogentity with Brad to solve a pervasive and complex challenge I've witnessed over a decade of working as a product executive in the Bay Area. Software company reporting structures are very complicated. Product workflow and resources even more so. Every company I analyze struggle to drive consistent and cohesive alignment across their organizations. Simple lack of understanding cause non-optimal results, misaligned incentives, inefficient spending, and missed targets, sometimes even failure. I realized we needed to solve 2 problems. One is clearly defining how each function and initiative within a company contributes to core business metrics. We call this practice business mechanics, discovering the actual structure and interconnections of the organization. The other is the ability to holistically visualize, explore, and interpret the organization's operations and behaviors. A 100-part structure that changes over time, where fatal problems can stay completely hidden unless the entire organization can be viewed as a whole. I could find no tool that comes close to letting business people do this, so we created one using cognitive engineering. As we open up this top block devoted to company valuation, Cogentity enables company executives or other key stakeholders, such as current or potential investors, to quickly see all key valuation metrics and core performance metrics on one page. Although it might seem overwhelming at first, it's organized into recognizably different visuals, following the business components an expert business person already knows. This one view replaced the 55 slide deck used at an actual board meeting, and it contains 3 times more information than we could put in those slides. Not only that, but it's interactive and everything is interconnected, not scattered across so many slides that you can't pull the ideas together for higher level insights or find multi-component problems. As a business analyst, the first observation I have here is that the 2 key metrics that drive the multiplier around the company valuation are below target: year-on-year growth and the EBITDA margin. If I drill into marketing to see if I can identify why the revenue is short of target, I can see that the number of market qualified leads is under expectation. So surely if I invest in additional marketing campaigns, I would fix my revenue issue and all will be solved. That is a typical conclusion people make, but not the real problem here, as I identified at one top 100 software company. If we continue to explore deeper and zoom in on the marketing and sales funnel, we can see that the real story is quite different. I can see by looking at the funnel that of the 2,400 market qualified leads generated, only 960 were followed up on by the sales team. 60% were blocked, completely wasted effort. If I applied the usual logic and bolstered marketing campaigns, it would only result in even more dropped leads. The live company model, that's the engine inside cogentity, lets me do a what-if scenario. If instead of giving money to marketing, I invested on alleviating the blockage, I'd be able to increase sales from 4 closed deals to 7 closed deals. Those additional 3 sales would surpass my target, close the gap on our revenue and our EBITDA margin goals. By addressing that one issue, all our red and amber progress metrics turn green, carrying our valuation metrics back into the green with them. But if we had more time, cogentity could show us several more subtler problems that could drive the valuation metrics even higher. Obviously, this is a lot of data to ingest in just 3 minutes, but hopefully this example shows the clarity cognitive engineering can bring to real-world complexity. These numbers are created for this example, but they follow a real use case that helped a real company fix its funnel efficiency and increase its valuation considerably. Cheers.
Now, Mark, as a financial analyst, naturally enough, is focusing on the financial impact of this. But if we make corporations 20% more effective, and personally, I think we can make them 500% more effective. Talk to me about that if you wonder why, using cognitive engineering techniques. Then the world will change dramatically because we'll be more involved, there'll be more transparency, and they'll be more effective at doing what I learned as an economist is our job, satisfying unlimited human wants with limited human resources. By the way, cogentity was, until you just saw that, a stealth company. We're hoping to bring it to market, sometime in the next 12 months. Thank you for being part of its debut. So in summary, I want to describe at a very high level, a meta level, the cognitive engineering design methodology. Hopefully, some of you are thinking, hey, how can I do that? And I hope none of you are actually thinking, oh, I can't possibly do that. Because what I was trying to do with my students, and this was a seminar, is make it into more of an engineering handbook, not a bit of brilliance while you're sitting back and contemplating the trees, for instance. So here's the outline for this talk, and let me bring us down through some things you'll recognize. 2, can this thing be learned? Yes. Very briefly, there are 3 key artifacts in the cognitive engineering design methodology. The mental model that we want to understand, that's an artifact of nature, if you will. Schematics and candidate designs. And then there are transitions between those states, as it were. From the mind, you extract and capture the mental model of an expert. Going from the mental model to a schematic, you have to support the tapping into every part of the pipeline we possibly can. Then finally, the purpose of a schematic is not to get a sign-off, but to test it, like the electrical engineering version of a schematic, and to then later map it to the technology for a candidate. We need to be able to say, that's a clever idea, but what's it actually going to be worth in the final product? Not let development budgets quash our best ideas. What we want to be able to do is have a way of saying, this is a way that we can enable our users so profoundly that you should give me another 2 weeks to put this together. And the only way to do that is a proper cost-benefit analysis. You say how much your 2 weeks are going to cost, and then we do a benefit analysis for the end user and see if that outweighs your 2 weeks by enough to pay your bosses. Here we extract and capture. I'm going to show, there are 2 outlines, 2 structured outlines, a workflow outline and a conceptual outline. Don't have time to go into them here. We do schematics. These are what schematics look like. They look like paper and pencil sketches because paper and pencil are absolutely the most flexible and understandable part of a conversation that you can have when you're trying to extract their mental model from somebody. Then we map to technology, as I said. And finally, there's something that's really interesting to me. I'm going to make a bold claim and then back it up immediately. I think the cognitive engineering design methodology can, in one of its very minor roles, do 100-to-1 speed up of finding bugs. How do you do that? Well, after you have a design candidate, if you make a separate paper page, a printout of every major state of the system, and you, as the representative of the system, holding this sheaf of states of the system, go and get your expert to sit at the other side of the table, and you hand them the first page and say, use the think aloud protocol. Pretend this is the actual screen. Sit forward and engage your actual mental processes. Don't sit back and say, yeah, that looks like it'll do it. That's not engaging your mental processes. Sit forward and try to work with this piece of paper, pretending it's a computer. And don't worry, when you click on something with your finger, I'm going to shuffle through my deck and show you what you clicked on. And if we need to fill in pages, I'll give you a pencil. And better yet, we will find bugs here. So I will immediately fix those bugs. Or if I don't completely understand it, and if I draw something that you don't understand, I'll give you, the expert, the pencil, and you will fix the bugs by drawing it right there into the schematic or into the design candidate. In a way, does one of the key things that agile programming was invented to do. Agile programming was, as far as I understand, invented because people thought they needed to actually get working systems in front of users to iterate properly to a full design. The idea was you couldn't actually deploy a version 1.2 that worked, and decades of coding and waterfall model proved that. However, if you can actually engage the expert's mental model by showing them pieces of paper, then you have a possibility of releasing a version 1.0 that actually works. And the beauty of that is it frees up Agile from cleaning up after waterfall. When you give somebody a new tool, it changes their workflow. It lets Agile jump into it and say, okay, here's the new tool, it works, but where can we go from here? I want to suggest there's a long way we can go if we work on honing our tools as opposed to just putting them together. And finally, hopefully you've seen these two images before, or at least you're familiar with these concepts. But on the right here, this is the Xerox Alto. And it looks pretty much like the systems that we use today as far as I'm concerned. There haven't been too many major interface design improvements since then. I'd be hard-pressed to say that we're twice as good as we were when this was out. But let's say interfaces today are 5 times better. On the right, we've got Moore's Law and how it's improved computers over that same 1971 to this ends at 2018. And the punchline here is while interfaces have arguably gotten 2 to maybe 5 times better, computers have gotten 50 trillion times better. I don't know how to conceive of that number, 50 trillion, but it's bigger than 2 to 5 times better. So I want to suggest that we need to start spending some time on the interface and on marrying the beautiful work we do as coders and the amazing capabilities, the 50 trillion times more powerful computers we have, marrying those better with the very reason that they exist, which is to support our thought processes. And I really appreciate you listening. Thanks very much. And thanks again, Astea, for bringing us together. Cheers.
Okay, so we are back to the Zoom meeting after viewing Brad's videos. And it's a lot of information to digest in condensed 40 minutes. A couple of follow-up questions, perhaps. First of all, Brad, thanks for doing the videos. They relate mostly to the finance industry, as your experience is there. Is there any limitations on where cognitive engineering can be applied?
Thank you for foregrounding that. As a matter of fact, finance is maybe a third, maybe even a less than a third of what I've addressed myself. And if you take my few hundred, maybe 200-300 students into account, we've applied this to doctors and lawyers and toll booth operators and social workers, and it always works for one simple reason. It's not about a certain domain of practice. It's about how humans invent domains of practice. We've gone down to that basic level of what does a domain of practice mean? How do you learn it? What's in your head? And so I was surprised, but it worked in every domain we tried it in.
Okay, thanks. And the question that often pops up, and we've discussed that in our pre-call, what is the relation between cognitive engineering and UX design? Because to some people at first sight, it would seem that they are very, very related and almost the same as a concept.
Good. So you said cognitive engineering, and what was the other word? I missed it.
User experience design.
Okay, good. I see actually there are 3 or 4 or 5 things that ought to play in, roles that ought to play into what's in front of the user. So if you are, so user experience design is often driven by branding. It's almost always driven by conventions. Always follow the conventions because this is what people expect and they want the search bar here and things like that. And that's all very important. We want to tap into what's in people's heads. So we want all of the UX experience. We want it to be sellable or be attractive. So branding is important. Another thing that plays into that is visualization. If you've got, 1 billion data points, you need visualization to show that. All those things play. All cognitive engineering does, it doesn't replace any of those. All it does is it says when to use those techniques and which techniques are going to fit this particular state of mind. Think of the mind as a state machine. When the mind is in a certain state, it must have the right things to transition it to the next state, or it stays in that state. That's what cognitive engineering does. It says, hey, we're in this state mentally. I need to tap into visualization, or I need to tap into branding, or I need to tap into UX to get the person into the next state.
Okay, thanks for that. There might be other questions, but we're quite tight on schedule. So as discussed, we can do a follow-up session if there's enough interest. But before that, a question that I ask every one of our speakers, which is, could you please complete the following sentence, which is, software development is... What do you think software development is to you in a single sentence?
Yeah, no, I thank you. I'm actually thinking for a moment about how to do that. It is controlling our worlds and our personal lives right now. We must get a better handle on its results so that we as individuals survive our current colonization by large corporations, our mental colonization, and our coming colonization, which is already starting, by AIs who can outguess us at every turn. We got to get better at it.
Okay, thanks a lot, Brad. It was a pleasure having you. We'll keep in touch over the next days. And once again, thanks a lot for your talk.
Geez, well, thank you again for bringing me such a fine audience and your attention. Bye-bye.
Bye.